what I'm saying? So from an English perspective, it makes sense. So this is the first time you've ever seen math that you can truly attack from the English side of things. You can attack these being equal from the English side of things. It's kind of neat. All right, like, okay, Jeff, whatever. You guys seen something else here, something bigger? Look at what have you been programmed to do in algebra when you see something like this?
To distribute.
Distribute. Notice one little thing that's a little different. You do distribute. And be careful. I want to make it really clear. You're not really distributing. It just ends up as if you would have distributed. Because otherwise you start distributing everywhere. And it just doesn't work everywhere. It only works in two places. Period. So what happens here? What do you get?
Negated P and negated Q.
Yeah. Careful now. That goes there. That goes there. But notice it also gets distributed to and changes it to or. So using that same logic, what do you think this would be incredibly enough?
Not
P and Q.
Not P and not Q. So it is just like distribution. You just have to remember actually that every single piece of it has to change. That's kind of a nice way to remember it. I really want you to understand. You're not distributing. It's just we're lucky that that ends up being equivalent to something that looks like it was distributed.
It's like greater than or less than.
That you have to change. I like it. Yeah. So I love it. I never thought about it like that. If you multiply divide by negative, then you have to flip the sign in an inequality. So that's exactly.
You multiply by negative, yeah.
Or divide. Yeah. So yeah, exactly. Beautiful. I love it. I never thought about it. All right. And I just want to show you an example of why you got to be careful. It's not really distribution. And real quick, actually, let me point this out. Section 3.4 is this. In section 3.4, you're going to make a truth table. You're going to make another truth table, and then you're going to ask you, are they equivalent? So 3.4 to me is sort of like a practice section, right? Practicing truth tables. Make a truth table, make another truth table, or are they the same? Right? Look at this here. This is definitely more complicated. Oh, before I get too far, this is these are called De Morgan's laws.
So
It's not a captain. Yeah.
on 3.4, number 6 is write a disjunction that is logically equivalent to a sign, or to P is arrow to.
Beautiful. And we're actually going to address that right now. Because the arrow gets freaky with negations and stuff.
You can't really flip it.
So that's the last thing we're going to do. Yeah, you can't make the arrow go the other way. You're not allowed to. You can't make it point up or something weird. It actually becomes a totally different symbol. So what the hell would this be? And this is, who remembers when I said, how do you find the negation of a statement? So if I said, some people in here are sitting down, how would you disprove that? Isn't that how you find the negation? To find the negation of something that you think, how would I show that they're wrong? That would be the negation. So if I said some people here are sitting down and you thought I was wrong, you'd have to actually go and find what?
Everyone's standing up.
Everyone's standing up where nobody's sitting down, right? Some are, the opposite is none are. So some of you guys remember there's that little table I showed you in that section that you can see that, right? Same thing here. To find the negation of this, I want to think about when is this not true? And this is the one that I kept coming back to, make an A, get a car, right? What was the one time that wasn't true? If you make an A, then I will buy you a car. What was the one time that we said you could be angry? Legitimately? You did your thing, right? So what am I going to write down? You did your thing. You did your thing. But, which is another name for and. I did not do my thing. And again, that's just a way to feel out what the answer is, just to think about what's the, to get the negation of them, you think about when would it be kind of false. Let me feel it out that way.
Would it ever be or? Or is it or?
In this, no, it can't be. So the only time, the opposite of this would have to be this, because this would be, you got your A, and, but, I did not get you your car, that's the one time that I would freak out. And you can make truth tables for both to verify that that they're equivalent. Yeah.
So why didn't you just distribute the negation to both sides?
Because again, did I ever up here anywhere distribute negation? No, I did not. I tried to make this point really good. And I understand, I didn't distribute here. It looks like I distributed, so it's easy to remember. We just got lucky that looks like distribution. We got lucky. Did we get lucky on that one?
No.
No. The arrow becomes an A. No. You can't look at it that way. I'm not going to make you memorize that one. Don't freak out. These you got to know. These are going to make you memorize and use. That one is not a part of De Morgan's laws. It's a good example of I didn't distribute. Because what would the arrow become? A star. Well, I don't know. What would it become? I don't know.
If, what about like an if and only if? Like a negated P, if and only if negated Q?
Oh, no. Well, that gets even freakier. And this is where you can start, like if you had this, that's where you start making truth tables and trying to figure out, is there another way to write that? What would it be equivalent to? Right? And this course is not a logic course. We're only in logic for one chapter, so we're not going to get deep into it enough to really get into the full algebra of these logics. So we're not going to worry too much about that. But this one I really want you to see, reasoning it out from English, it makes sense. If you made a truth table for this and a truth table for that, they would have the same outputs. They are logically equivalent. And it does make sense from an English perspective also. Cool. All right, so next time we're going to get into fallacies. We're going to talk about different types of ways to misinterpret logic. Yeah. Some of us are discovering that already. What's that? Likes. Yeah, I guess it says and likes.
Yeah.
It's not like so the trick on this one. So I think it said but is not like it. So it'll be another and. That's the problem. Because right now, look here. Right now, there's no symbol between the Q and the not R. There's nothing that can tell me to do it. So I bet you anything is a but. Oh, I got it right here. Oh, yeah. So one thing is, notice also the parentheses. I mean, like it's the comma. Because right here, because otherwise, I wouldn't know which one to do first. But see where the comma is? You separate this idea from the other two. So these should be together. And there's an and has the same. Okay, cool. Thank you.
The ones that are giving you.
No, those are the ones that Q will turn in. I haven't had time to grade anything.
And then I forgot one thing. When for this answer, do you want us to explain how the answer is? Because
You didn't have to write it separate, you had to write underneath it.
because it's obvious a pattern. Can I write it? Sure.
Like here you could write like theta times 2 times.
I just did I showed what I did. Oh, I don't have to write a sentence.
No.
And then I did so I need to try that way.
Yeah, when you make corrections, you just do those. Like I said, I mean, let's say you get like a 40. You make corrections, you can get up to 55. And then you get like an 80 on the test. You get all the corrections right, I'm going to make your quiz grade an 80.
Okay, because yeah, I can't. Word problems I need more time.
Okay. No word problems.
This one.
No, it's not a word problem.
What was the word problem? I need like more than 2 minutes.
Go ahead.
Oh, I just turned in my homework, but I just want to say I accidentally wrote some of my notes on the back of 3.1, but so it's just on one side, so it looks like the back of it.
So if you can live
Is that
without
okay?
for a little bit, okay?
Yeah, I have notes on the back which didn't have anything to do with it.
okay.
This is in my notebook, and then I have. Oh, right.
Yeah.
I swear I do not have a stapler at my house. So.
Oh, that's right.
I corrected these, except for on this one. I'm not really sure what you want me to do.
Oh, this is the one again. This is the one where you're gonna.
Yeah.
You do what you did, but you start with X.
Okay.
And then you multiply it by 4, so you get 4x, and then you plus 6, and then you divide it.
Okay.
You gotta do so a little bit of algebra. And that's why, you know, the deductive reasoning is always more difficult. You gotta
Right.
start with the general, which normally
With
is
the
a
variable.
variable. Yeah.
Did you look over the homework that we turned in on, Monday?
I had some, what's your name?
Yes.
Oh, you mean this Monday?
Yeah.
No, I haven't had time.
All right.
Yeah, this weekend. Oh, normally at weekends are my catch up on grading time.
All right.